Got it. Okay. Let me go back to show you. All right, so without further ado, we are going to jump back into what we did last time, which was working on models and animations. And so we had a good stopping point. Excuse me. We had implemented the models, we had downloaded them, we had set up their rig, we had pulled them into the game, and we had stopped at the point where we needed to start plugging in the animations. And so that's what we're going to do today. We're going to look at how to get the animations set up and how to do all that sort of stuff. So quick recap: when we hit play, this is what we get. Our mouse goes to, or the little mouse character goes into the idle animation, and it stops there. We're eventually going to get rid of this brick and this red and yellow character, and we're going to replace it with these guys. Okay. And so first step today, we are going to work with getting our mouse, the literal mouse, not like the on-screen mouse, getting our character moving with animations. Okay. And so first thing I'm going to do is I'm going to take these two bad guys and I'm going to shut them off. Do that just by turning the game object off right there. That way, when we run it, we don't have anything chasing us. Okay. Now let's go to our player. And we also have our, where's our mouse? Our mouse is right here. Okay. We have our player. And we're going to want to take this player script and transfer it over to the mouse. Okay. And so, in fact, what I'm going to do is I'm just going to delete this player altogether. He's going to go away. And then on our mouse, I'm going to drag and drop our player manager script here. Okay. So this is going to give us access to our player. And let's go ahead and pull up this script and let's take a look at what we've got, because we may not need all of the stuff that we had there before. Okay. For example, we had the player transform and we had the rigid body. And so let's get rid of this rigid body for now. All right. And so inside of updates, we had some different movement vectors. We had some on collision enters and we had jumping. We're going to get rid of all of that for right now. Okay. All right. Generally, the way that I like to organize my scripts like this. All right. I do region, startup functions up here, which would basically start, awake, and any initialization functions. Okay. And so that's one section. And then I do another section for update functions. And so this would be update and fixed update. And then I'll do a section for collision functions. So that's on collision enter, trigger stay, all that sort of stuff. And this just helps organization a little bit. All right. And then here we'll have movement functions. Okay. Or we'll call this movement input functions. And you'll say private void move player. Okay. So inside of updates, I'm going to get rid of this and simply make a call to move player. So the way in which we're going to move the player is going to be different from how we have moved the ball. We're not just going to simply set the velocity or set the position. We're going to be moving the character using the root motion of the animation. And remember, root motion is built-in movement data to the animation. So the animation actually contains the data for how much to move the character, how much to rotate the character, and all that sort of stuff. Okay. So player speed is no longer needed. Neither is jump speed. Neither is jumping. So we can get rid of all of these because all of these are going to be determined by the animation itself. Okay, so really the only thing that we are messing with is the health is all that we need right now. Okay, and in fact, we don't even need the player transform. All right, so get rid of all of these. All right, and so we've stripped this down pretty well, but we are going to need access to the animator. Okay, and the animator, if you recall, if I go back to the editor, the animator is this right here. The animator is what controls what animation is playing and all that sort of stuff. Looks like we've got an error because our bad guys in our camera use the player's transform. Okay, so we're going to need to put that back on there. Private. Actually, I think this needs to be public because other things access it. Okay. So we've got that. So I'm going to drag and drop player transform here. I'm also going to drag and drop the animator here. Okay, so now we've got access to both of these. This is the animator component. This is the transform. And now we've got access to those. All right. So I try to make it a habit of whenever I make big changes like that, just running it, make sure that we are good. We're running it and we've got errors. All right, this is, let's see what error we've got. Player manager dot player transform. Looks like we need to go main camera and drag a reference to where's our mouse? Right there. Okay. Now our camera knows who our player is because we changed it from being one to the other. Okay, so we're good. Our character is properly in idle. All right, so now let's take a look at the player controller. So this is our animator. So I'm going to double click on this and that pulls us up to the animator tab. And we see that this is what we have inside of it. So we've got a couple different rectangles, and these rectangles represent animations. Excuse me. So don't worry about this any state or exit right now. We don't really need these. Entry simply means this is the default state. So when we first run this, whatever the entry is the animation that's going to play. And so we are playing the idle animation, which is just standing still right away. And the idea here is as we detect input, we want to transition from idle to run. And then as the game no longer detects input, we want to transition from run back to idle. That's the idea. That's the goal for what we want to do here. Okay. So in order to do that, we need to first decide how we want to do movement. Okay. And so generally what we want to do is we want to we're going to think about how we want to move. So we could do it to where we are always walking forward, and then we simply rotate based off of the angles that are pressed. And so, for example, if you pressed W, you would face forward. If you pressed S, he would turn and face backwards. But he would always be walking forward in the direction that he's facing. And so let's do that first. So let's go over to here, and we'll go over to Player Manager, and we'll do Move Player. And what we want to do here, so inside of Move Player, remember this gets called once in update. What we want to do here is we want to write the code that first, we're going to say rotate player to face the input direction. Okay. And so here's how this is going to work. We're going to take input in 4 directions, up, down, left, and right. And you can use this. You can use the input get axis. We can try to see how that works. So let's try H equals input dot get axis. I think it's horizontal. Is that right? I think if you go into, it's been a while since I've done this, project settings, and then you go to input axes, horizontal. this is where you can specify that. Okay, so horizontal and then vertical is up, down, and then it has these keys built into it like that. And then we'll V for vertical input dot get axis vertical. And then so I'm going to print these out. Just so that we can see them, and then run this. Okay, and if we look at this, as I press up, so I'm pressing W right now, and this slowly goes from 0 to 1. Not slowly, but it goes quickly. If I press S, it'll go to -1. If I press D, it'll go to 1. Notice we're changing the horizontal now, not the vertical. And so if I press W and D, which is up and to the right, they're both 1. If I press A and S, which is left and down, we get -1, -1. So these are values from 0 to 1. So it's working exactly how we want. We can also use the arrow keys to do the same exact thing. Okay. So now what we want to do is we want to rotate our character to face the angle of input that we are doing. And this is going to be a little tricky. Let me see if I can do this off the top of my head. But essentially, here's how this is going to work. What we want to do is, we obviously know that we're getting a value from +1 to -1 on both the upwards and downwards direction. So if this is our character, those are supposed to be hands, but I don't do it well. Essentially, what we have is we can pretend like we have a circle around him. Okay, like this, where this is +1 on the vertical axis. This is -1. This is our horizontal axis. This is +1. This is -1. Okay, we can think of the input set up like this. And so what we are actually going to do is every frame, because move player gets called every frame, essentially what we are going to be doing is we'll have this circle, and this circle represents the input vector. And so, for example, if we are pressing if we're pressing up and to the right, which is W and D, we're going to create this point out in front of the character. Okay, if we are pressing just S, which is straight down, that point will be behind the character. Okay, so we're going to use these input values of H and V to create a point out either in front or to the side or wherever it is, somewhere around the character. We're going to create a point using the input and his current location. So we're going to take his current location, and if the input happens to be 1 for vertical and 0 for horizontal, we would create a point that is 1 unit out in front of where the character is facing. Does this make sense? Okay. And so let's just say that H is -1 and V is 0. So we are pressing directly to the left. We would take the character's current position, and then we would create a new position that is 1 unit to the left, or -1 of where he is. And then he would simply face that direction. Okay. So let's code that. So we're going to say vector 3 input direction equals new vector 3, and then we'll say H for the X, 0 for the Y, and V for the Z. Okay, does that make sense? We good on that so far? Understand why we put those there? All right. And then we are going to say vector 3 face direction equals player transform dot position plus input direction. So we're going to take the character's current position and add onto it a point that represents the input direction. Okay. Now, let me show you something. There's this debug.drawLine So we'll say we're going to start it at player transform dot position, and we are going to go to face direction, and we'll say color dot red. What this is going to do is this is actually going to show us a line inside of the editor so we can see exactly where this is pointing. Let's save this and let's run this. And let's actually go into the scene view. We can do it like this. Okay, we'll go kind of closer. And so as I press up, we can see how the line gets drawn around him. And so basically we're going to want him to face that point at all times. Cool. All right, so that's how you use debug.drawLine. All right, now we want to, well, we'll include all this. So the way in which we are going to rotate him is we're going to use lerp rotation. And so we'll say quaternion, UATER. Right. I can't spell. We're going to say target rotation equals quaternion dot look rotation. Right. We'll get to that in a second. First thing that we need to do is we have the direction we want to face, but we need a vector that points to that. So we have to subtract the face direction from the player transform dot position. Okay. This is get vector from player to the input direction position. Okay. And if this is easier just to add on to this, it might be. So isn't that just input direction? I don't know if it would work that way. We'll try it like this and see if we can. Once we have it working, we'll pull that out and see if we can just use that. You might be right. It's been a while since I've done this. Okay, so this target rotation is exactly what we want the rotation to be. So I'm just going to snap it to this for now, and then we can add in lerping in just a second. All right, so what we've got here is we're getting the rotation needed to point there, and then we actually just set the rotation there. So what we're going to get is a very snappy rotation of the player. You can see as I go from one to another, it's a snap rotation in that direction. Okay. Let's test the theory of whether or not, I don't think we can. If we just take this input direction, I don't think we can do it like that. No, it's not working because it's using 0, 0 as the basis. So that doesn't work. I thought we needed to do this. Either one. All right. So to get rid of the snappy rotation, what we need to do is we need to use lerp rotation. So we're going to say quaternion dot lerp, and we are going to take as the starting point the player's current rotation, use target rotation as the goal, and then we are going to say look speed times time dot delta time. All right, and look speed is going to be a variable that we are going to create up here. Let's actually call this rotation speed. Set this here as 5. That's pretty good. So now when I go from straight up to straight down, we get a nice turning. Cool. Any questions? All right, if I'm not pressing anything though, he defaults back to that. So we don't want that. We want to leave him as is. So what I'm going to do is I'm going to say if H equals 0 and V equals 0, return. Do nothing if the input is not. You can do it like this. You can wrap all of this code below in an if statement instead. I prefer this. Just, I know if we're not detecting input, then we return and none of this gets run. Okay, so this should allow us to now, when we face a direction and then stop pressing keys, just to keep there. So I'm not pressing any keys. I can turn and whatever the last pressed input is going to stop there. Okay. All right. I know I'm moving a little fast, but just ask me if you have any questions. Okay. So this deals with rotating the player. In fact, what I would like to do is let's, well, we'll leave it. Now let's deal with moving the player. So I'm going to take this and move it down here, because that comment has to do more with. All right, so now let's actually move the character by playing the run animation. Okay, and this is let's just get into this rather than me talking about. Let's just get into this. So basically the way this works is I'm going to go back to our animator, and you can get it by double clicking on this or just by going to the animator tab. The way this works is we need to specify conditions under which we want to travel from one animation to the other and transition back. And here's how this works. With the animator tab open, you're going to go over to this parameters, and we're going to create a parameter. A parameter is simply a variable that exists in the animator, and these variables are going to be the basis for the conditions for swapping animations. Okay, and so I'm going to create a float, and I'm going to call this speed. Okay, and speed is essentially whether or not the player is inputting values. Okay, then I'm going to come right here to the animations idle and run, and I'm going to right click and create and click on make transition, and that gives me an arrow, and then I'm going to go to run. All right, and then I'm going to click on the line in between. Okay, and that clicking on the line pulls up some stuff over here in the inspector here. And so what we've got here is we can see the animation and we can see the transition between idle and running. The top one is idle and the bottom one is run. So this is what we are transitioning from to what we are transitioning to. And the blue represents what animation the character is playing. And you see right here, this is the overlap. This is the transition from idle to run. And Unity has a really nice built-in transition system that will automatically blend animations together, which is really useful, okay? And so what we've got here is we can see how he goes from idle to running. Okay, so this is great. That transition is fine, but there are a few parameters that I need to explain to you. The first is has exit time. And this is tricky. People get this confused a lot, or people struggle with this. What this means is exit time refers to the amount of an animation that has to play before a transition will occur. So if you want a transition to occur immediately, you want to uncheck has exit time. All right. If you leave has exit time, that means a portion of the animation has to play before you will allow it to transition to another animation. All right, for example, in Access Football, the running animation, so that from going from idle to run does not have an exit time checked. As soon as the user presses up, presses input, we want to transition out of that. We don't want a certain portion of the idle animation to play before we transition. We want to transition immediately. So has exit time is not checked for that. However, there are like tackle animations. So you get tackled, and even if they're pressing a run or pressing a button, we don't want that to happen until enough of the animation has played, which is basically all of it getting knocked down and then back up, before we want to allow transition out of that. Okay, so for most of these movement animations, you are going to leave has exit time unchecked because you want to allow for animations to play, or you want to allow for animations to transition out. But if you had like a jump animation or a rolling animation, you would want those to play completely before transitioning out of them. Otherwise, it would look really weird to be in the middle of a roll and then start running again, like pop up out of that. And so you want, that's what that is. If you want a certain portion of the animation to complete before transitioning, you'll leave has exit time, and then you can specify what that exit time is. It's done on a scale of 0 to 1, which is a percentage of the animation. Okay, that's what it's done. We do not want that. We want to be able to transition out of idle immediately. And so we will leave that as is. Okay. All right, second thing. These are just parameters that specify like how long the transition could take. You can move this around. So this is kind of like a visual representation. If you want kind of a smoother transition, it doesn't really matter. 0.2 or 0.25 are usually fine for a transition. Now we get down here, the conditions is the big thing. So this is remember, we clicked on this line, and we need to specify the condition for when we want to do that. So I clicked on the plus, and it pulled up this list right here. And you'll notice this speed is the only option we have available because that's the only parameter that we've created so far. All right, so if speed is, we have greater, less, and equal to as options. If you have an int value, you also get an equal to. So if speed is greater than 0.1, we're going to want to transition from running or from idle to running. And likewise, I'm going to go right click on run and go back to idle, click on this. We're going to uncheck has exit time. And then for conditions, we're going to say if speed is less than 0.1. Okay. Kind of makes sense. And that's how we're going to set this up. So now what we need to do is, because we have this speed here, we need to be able to communicate with the animator and adjust these parameters based off of the user input. Okay. And so let's go back over to my project. And we have a reference to the animator already. Okay. And so right here, what we can do is we can set that parameter by saying animator dot set float. Okay, because we set up speed to be a float value. If we set it up to be an int, we would call set integer or set string, whatever it is. So set float, and you notice right here, we have an overloaded method. We can either access that parameter by an ID value, or we can access it by a string value. It's best to access it by an ID value, but you have to, I don't know why I'm yawning so much. You have to set up hashes for that. And in the interest of time, I'm not going to do that. So I'm just going to say speed, because that's what we call it. And then we're going to pass it in a value. And this value is going to be a value from 0 to 1 based off of our input. Okay. And so we're going to call this speed value. We're going to pass in speed value, but we're going to need to define. Okay, so you say split speed value. And so let me ask you guys a question right here. What makes the most sense for how to set this value based off of our two inputs? Because we already have them facing the direction, but as long as we are pressing any key, either as long as H or V is not 0, we are going to want to use that value. Okay. And so what would you suggest that we do in terms of setting this speed value based off of H and V? All right. So we've got one person saying use the magnitude of the input direction vector. That is a good option. Does anybody have another option? Absolute value of all and divide by 4. Why?
Wouldn't the absolute value prevent you from going left or back?
No, because we're only ever moving forward. And so by changing the rotation, that has us moving that direction. And so whether we're pressing left or right doesn't matter. We're still moving based off of that. And so yeah, there's a couple of different ways you can do it. You can simply take the max between H and V. You need to take the absolute value first, because we wouldn't want negative to factor in. And so either of that would be fine. Taking the magnitude of the input direction would also be a really good option. I'm just going to use that because it's probably shorter code. Yeah, the run animation does move forward. We're not actually moving here. All we are doing is telling the animator that we want the speed to increase based off of the input, and the animator will then take that speed and transition from idle to running. Okay, and so I'm going to say input direction dot magnitude as our speed value. Okay, and magnitude, if you recall, is simply the length of a vector. And so remember that red line that we were drawing and it was getting like farther from the player as we put it. That's essentially what is represented by here. Now we do have a little bit of an issue, and that is the fact that we are doing nothing if input's not detected. And so if we allow this to continue, the game won't ever tell the animator that nothing is being pressed, since we stop when nothing is being pressed. And so what I'm going to do is I'm going to need to adjust this to say if H does not equal 0 and V does not equal 0, then do this, which is the opposite of what we had before. Okay, and get rid of this. I'm going to need to pull this. We're going to need to pull this up here so we can use it down there. Okay. All right, let's see if this works. I'm not pressing any keys. I'm not rotating. Okay, right now I'm pressing directly down and he's not going. Now I'm pressing directly left, up. So he's running. Something is not working correctly. So here's what we should do. First thing is I want to if H is not equal 0, I want to make sure that we're and V does not equal 0. Yeah, the if statement is faulty. What's wrong with this if statement? So remember, this is just rotating the player. This just has to do with rotating the player. That's correct. All right, so the issue was if we aren't pressing both keys, it's 0. So that is the correct answer. We need an or. So now we can properly rotate and run wherever we want. Well, the problem is he's not actually stopping. And he's a little slow on his turning. I don't like how slow he turns. And so I would like to. Here's also the problem. As soon as we let up, so let's say we're running down and I press up and I just tap it for a second. He'll turn partially, but not completely. And the reason for that is this stops running as soon as I let go of the key. And so what we need to do is we need to continually move the player based off of this, but we only want to update it if he's pressing the input. Okay, and so this is problematic. Let's do one thing at a time. Okay, so first things first. Let's do this. Why is the character running as soon as the game starts, even though we're not pressing any keys? Who can tell me that? Why is the character running as soon as the game starts?
Small question. What's going on with the speed value? Where do you, oh, is there a thing where you set the speed value to 0 at any point or something less than 0.1?
So it gets derived from this up here. And so at the very beginning, H and V should be 0. And the magnitude of the 0 length vector, it should be 0. This is the reason right here. And so because we're taking the player's position into account, that's what's causing the input vector not to be 0. All right, and so what we need to do is we can simply say, we'll go math vector. We'll take the maximum of the absolute value of H and the absolute value of V. Because if they're both 0, then that's what we'll pass in. Okay, so this was the second solution, taking the max value of the two rather than using the magnitude of the input vector. So let's see if this works. He should start off standing still, and if I press forward, he transitioned to run. If I let up, he stops. Okay. If I turn left, we start running. If I turn this way, I think he gets confused for a second. I think what I'm going to do is try to increase the turn speed. All right, so question, how would you deal with the player rotation while using the forward point of the camera's rotation? Using the forward point of the camera's rotation. I don't know that I understand your question. Since forward is right now. Yeah, so you would simply, all right, go ahead. I'll let you explain a little better because I'm not sure that I understand. While you're explaining, I'm going to increase the speed. All right, so do we see here? What do you notice about the character's Y position? Yeah, it's like he's slowly sinking into the ground. Let me show you how to fix that. All right, so we go into the animator. We're going to go to both the idle and the run animations. Okay, so you can double click on them to get to the animations. Remember, this is where we put in loop time. Here's what you want to do. There are some parameters here. There's the rotation, the Y position, and the XZ position. And what we want to do is we want to click bake into pose for the Y position. All right, what that will do is that will make sure the character's Y position never changes. It gets baked into the animation. So I'm going to do the same thing here for the Y position. I'm going to set this as a. So now when we run it, he should stay in his position. So as we run, he never goes back into the ground. Okay. Now, what you can do if you want to increase how fast he moves is you can change the speed that the animation plays. So if right here, you want to click on speed, we can increase this to like 1.2. And then he'll move a little bit faster. Cool. All right, so now let's reset up our collisions. We'll go to the rat, and here we're going to add a capsule collider. Or mouse, not our rat, I'm sorry. So let's add a capsule collider. And let's adjust the capsule collider a little bit so that it fits our character. You generally do it so that it fits like shoulder width. This is pretty good. Let's go 0.2 and then generally this is going to be half of what this is. So this is 1.2. We see how we kind of set the collider to be the size of the body. And so now let's see if we can get these. It's not healing us. Do we know why it's not healing us? I think the tags were on these. So tag is goal, tag is healing. A lot of times when using on collision enter, you need a rigid body. Okay, you need a rigid body on these. Let me run this. And we see now that we have a rigid body, what's happening? It's like he's running in a hurricane. Okay. Couple things. It's possible that our collider is colliding with the floor. So first thing I'm going to do is I'm going to move the collider up and see what happens. Okay, that's not it. Okay, so move the collider back down. Okay. Second could be the drag. Although oh, well, this is a problem. So what we have here is as we press forward, he is being pushed to the ground like this. This looks pretty silly. This is not what we want. The way we can fix this is by going into constraints, and we're going to want to freeze the X and Z rotation. Okay, X rotation is this way, and Z rotation is this way. Okay. And so now we'll run it, and we're good. Why is he shaking like that? Okay. You see, now it's properly working. Yeah, he's nervous. Well, he's a mouse running around. I don't know why he's running like that there. Wonder if it's gravity. Let me shut gravity off.
Oh, I think it's due to the interpolation option in the rigid body. I had to like correct that when I was setting it. Interpolate. Yeah, I just set it to interpolate.
I thought that was the default value. Maybe it's just the run animation. Just doesn't look like it's running correctly. It shouldn't be that. Discrete should be fine. Continuous is overkill. And then we don't need is kinematic. That's if we're all right, that's better. Let me try freezing the positions, because we're only ever moving forward. That's better. But now we can't. But it's like there's some weird force pushing him left and right. And you can see it here as he walks. He's like he's going up and down. It's not this. Try baking this in. If this works, I'll explain what I did. All right, that's it. All right, so that's much better. There's two things. One, I've been working with Unity for almost 10 years at this point. And even simple things like that mouse moving, it took me a little bit of time to figure it out. You just have to play with stuff. And so I just tried a bunch of different things. Two, what actually fixed it was similar to what we were talking about before. You can bake things into the animation. And what that means is that will prevent, so if something is baked into the animation, it will prevent the transform from actually being affected. And so what I did, or what the animation had some slight rotating that was happening. It was just a part of the run animation. Like as they run, the character would slowly rotate. And what was weird is because we were rotating the character in code, the animation was also rotating the character, and the two were fighting against each other. And so by baking it into the animation, the character still rotates, but the transform wasn't affected. And so the two were no longer fighting against each other. And so that's why baking it into the animation fixed it. All right. Character's also moving a little bit too fast, or a little too slow. I want him to move a little faster. So I'm going to decrease the drag a little bit to allow him to run a little faster. Okay. So now he doesn't fall off because we have his Y position frozen. So let's uncheck that. That was one of the things that I thought might be causing it. So we're running, and now we can fall. Cool. So I want to see, to me, it doesn't look super smooth. It looks like he's like hopping on the ground. No. Okay. All right, we got a little bit of time left. That is a good stopping point. So one thing you can do is you can pull up the animator at the same time that you are running the game, and you can kind of see exactly what's happening. So here we're in idle. As I press up, we transition from idle to run, and as I let go, we transition back to idle. And if you notice, if I do a very quick turn from one to the other, we transition to idle just for a second. Now, in this case, that's not bad because it gives like a realistic pause between the two, but we could remove that if we wanted. All right, so we'll stop here with this. Let me go ahead and answer Sam's question. Go ahead, bud. All right, so in a game that uses an over-the-shoulder camera, when the player pushes forward, the character moves in the same direction the camera is pointed. The actual direction can change just by rotating the camera. Compare that to games with a static camera where the character moves. Okay, so what you would do is if the character always moves based off of the camera, then you would do the same exact thing we are doing here, only you would rotate the camera in addition to rotating the player. You would simply rotate both. Now, generally, you're going to need an offset position for the camera. And so we could do that same thing here if we wanted the character, or excuse me, the camera to stay with the player. So for example, if I turned left, the camera would swing behind the player. That would work. You could do that as well. And the way that you would do that is in your camera script. So if we pulled up this camera manager, the way this works is we simply have an offset where the camera is always 6 units above and 7 units behind the character. But this doesn't take the character's orientation into effect. It simply takes the character's X position and Z position and adds in the camera offset. Okay, and this Y position is simply where the camera should be. This should be. Well, we just have it 2 units higher, but that's fine. And then we're constantly. You said, oh, I meant the camera being free from the player rotation, not necessarily following a character. I'm thinking. So as the character moves, the camera is free to rotate around the player. Are you talking about like in Breath of the Wild, where you can run and the camera's here, but you can still be running forward, but the camera moves around? Like that? So in that case, you simply need 2 different inputs, one that controls the camera rotation and one that controls the player rotation. Yeah, you just need 2 separate inputs in that case. And then when you push forward, instead of rotating based off of the input of the player, you rotate based off of the forward vector of the camera. That's what I do. I'm thinking, yeah, that's what I would do. Okay. No, I'm glad you asked the question. That's a good question. What other questions do you guys have for me? Okay, all right, well, we will stop here for today. It's a good stopping point. What I think we'll do next time is we'll pull in some additional animations, maybe a jump, maybe an attack. We can pull in our enemy and add in some stuff as far as that goes, but we'll keep adding some animations to it. So hopefully this was beneficial for you guys. I'll make sure this gets posted up online and we can go from there. Stop share.